In problem 6, we're going to use the same equation that we used for the first few problems, but you are given slightly different information in this problem. What we're doing here is taking a stock solution, a 6% stock solution, and you have 12.5 milliliters of that, and you are going to dilute the entire solution down to 0.5%. So we're not just going to take a certain portion of the stock and dilute it, we're going to just add water directly to the stock, and you need to know how much to add to dilute it down to 0.5%. Okay, so in the first few problems we always started out with stock solution on the left side, so we're going to do the same thing here. V1 is going to be 12.5 milliliters. C1 is 6%. We need to figure out what the volume of our diluted solution is going to be, so I'm going to leave V2 as the variable, and C2 is 0.5%. Okay, now if we multiply that out, we're going to get 75 equals 0.5 times V2. Divide each side by 0.5. And you get 150 milliliters is V2. So you can make 150 milliliters of the 0.5% solution. But we really haven't answered the question. We just need to fill in one little piece. The question asks about what volume of water you need to add to go from the stock volume to the applied volume. So in other words, to go between these two solution volumes, you are going to have to add 137.5 milliliters to dilute that stock out to 0.5%. So you just find the volume of the in solution, and then you have to do that intermediate work of calculating the volume of water to be added. So this is your final answer on number 6. Okay, on number 7, you have a little bit of work to do before you can plug in to your volume and concentration equation. I want you to notice that your stock solution is expressed in the units of percentage, and your solution that you are going to apply is expressed in terms of milligrams per milliliter. Okay, so if you need to convert between these two, if you have a solution expressed in percentage and you want to go to milligrams per milliliter, normally you would want to multiply that solution concentration by 10. And if you are going the opposite direction, you have milligrams per milliliter, and you want to go to percentage, you would divide by 10. Okay, so I'm going to take the 9 milligrams per milliliter, and I'm first going to convert that to percentage. So 9 milligrams per milliliter divided by 10 will transform the units. So you get 0.9 as your number, and now you have a concentration of percentage. Now we're going to plug into our volume and concentration equation. So we're trying to figure out how much volume of stock solution you need, V1. The concentration is 4.5%. You are going to get a V2 of 0.75 liters, and the concentration is going to be 0.9%. Okay, so I'm running out of room a little bit, so I'm just going to describe the algebra here. You want to multiply 0.75 times 0.9, and you are going to divide that by 4.5, and you would get the volume of stock solution you need is 0.15 liters. Something you should be able to do is easily convert between liters and milliliters, so you may also express that as 150 milliliters. To go from liters to milliliters, you want to multiply times 1,000. Okay, now in number 8, we're going to do something a little different where you are using 30 grams of a drug. So you have a solute and you have a goal to use that entire substance, and you are going to dissolve it in a solution so that your solution of the drug is 15 milligrams per milliliter. So I think the easiest way to do this is to set up a simple dimensional analysis to cancel out the units. So let's take our 30 grams of drug, and we're going to multiply that times the concentration that you need to make, which is a 15 milligrams per milliliter. So notice what I'm doing is I'm setting up this problem so that the unit I need, the volume of water, is going to end up on top. So liters is going to be my initial way of solving for the amount of water. And then we need to get rid of both of those mass units. We need to get rid of the milligrams and the grams. So the relationship between those is that you have 1,000 milligrams in 1 gram. Oops, I realized I made a mistake here. This is supposed to be, the problem gives the information 15 milligrams per milliliter, and I just left that M off there. Okay, so when we solve this, you're going to get milliliters as your answer because the grams cancel out, the milligrams cancel out. So if we multiply straight across, 30 times 1,000 is going to give you 30,000. 15 times 1 on the bottom is going to give you 15. Divide that out and you get 2,000 milliliters, because that's the only unit we had left in the problem, will be the amount of water you need to add to the 30 grams of drug. Okay, and lastly, we're going back to that idea of a dilution represented by this ratio. So anytime you use that in a problem, you just make it as a fraction. So we're going to change that to 1/40. Here we're given the final amount of solution you need, and you don't know the amount of stock solution. So we're going to make that as your x. Always put the stock on the top. And then you need to make 3.5 liters of the applied solution. So again, we need to cross multiply this one. 40 times x And then on the other side of the equation, 1 times 3.5 divide each side by 40, and x will come out to be 0.0875 liters. And that would be the same as 87.5 milliliters. Okay, so the basic idea here is that if you have a bottle of stock solution, you don't need to necessarily know the concentration if the directions on the bottle tell you to make this 1 to 40 dilution. So if you know for whatever you're doing in the clinic that day, you need 3.5 liters, then you set up this basic equation and you know you are going to need 87.5 milliliters out of the stock bottle and add water to that to get up to the goal you need of 3.5 liters.